The learning goals are to understand the difference between solar and lunar eclipse and that there are total and partial eclipses. An illuminated object casts a shadow that consists of an umbra and a penumbra. These regions arise because of the partial versus total obscuration of the light source. In the umbra, the sun can't be seen at all. Eclipse means obscuring the light from a celestial body. In a lunar eclipse, the shadow of the earth is cast on the moon. The moon is obscured. In a solar eclipse, the shadow of the moon is cast on the earth. The sun is obscured. The name is always the object that is being eclipsed. For an eclipse to occur, the sun, the moon, and the earth have to be in the same plane. Eclipses don't occur every month because Earth's and the moon's orbits are not in the same plane. If the moon crosses the plane of the ecliptic, the path of the earth and the sun, and is also aligned with the sun and the earth, then an eclipse occurs. Lunar eclipses only happen 2 times a year because of the tilt of the moon's orbit. As the animation of the March 14, 2006 penumbral eclipse of the moon shows, during a penumbral eclipse, the moon is only traversing the penumbra. As this NASA diagram of the lunar eclipse of April 14, 2014 shows, during a total lunar eclipse, while the moon is in totality, which is while it is in the umbra, it becomes a bright red color. It's the color of the moon in the umbra. This is due to the moon being illuminated by light that is refracted around the atmosphere of the earth. A lunar eclipse takes hours, and during this time, the moon changes color. Again, the red near totality is due to light from the sun refracting through the Earth's atmosphere. When in the penumbra, the moon is gray. The circular shape of the Earth's shadow on the moon led ancient Greeks to believe that the Earth is round. This diagram shows the timing of the total eclipse of the moon that happened on September 2015. Lunar eclipses last for hours. To summarize, a lunar eclipse occurs because the Earth is between the moon and the sun. It is visible over a wide area on Earth and lasts for hours. A partial eclipse happens when the moon is in the penumbra. A total eclipse occurs when the moon is in shadow. Lunar eclipses occur at full moons. Eclipses do not occur every month because the moon's orbit is tilted about 5 degrees with respect to Earth's orbit around the sun, which is the ecliptic. Eclipses aren't at the same time every year because the nodes and apsides of the moon's orbit precess. The aerosol content of the atmosphere, including volcanic eruptions, gives rise to different eclipse brightnesses, ranging from a bright copper to a dark brown or even black. Daniel created a scale of lunar eclipse brightnesses for observers to make comparisons. Amateur astronomers look for atmosphere conditions and other events while observing lunar eclipses. AstroBob recommends looking for a bluish tinge caused by refraction due to the upper atmosphere ozone. In contrast, solar eclipses are due to the Earth being in the moon shadow. Solar eclipses happen at new moon. The Earth traces out a tiny line on the Earth of totality. People have to travel to the eclipse location to view it. Because the distance to the moon varies, there are 3 types of solar eclipses. Total, the moon completely blocks the sun. Partial, only part of the sun is blocked. And annular, The sun appears as a bright ring surrounding the dark moon. This Pearson graphic shows all three solar eclipses. An annular eclipse, as seen in the bottom, has a ring of sun outlining the lunar disk. These occur when the moon is closer to apogee, its farthest point on its orbit. The total eclipse occurs for a narrow region on Earth and is short-lived. These occur when the moon is closer to perigee. The partial eclipse occurs everywhere in the penumbra. The following movie and caption are from the NASA Visualization Studio. A solar eclipse occurs when the moon's shadow falls on Earth. The shadow comprises two concentric cones called the umbra and penumbra. Within the smaller central umbra, the sun is completely blocked by the moon, and anybody inside the umbra sees a total eclipse. Within the larger penumbra, the sun is only partially blocked. In this animation, the umbra and penumbra cones are viewed through a telescopic lens on a virtual camera located far behind the moon. Long focal lengths, like the one used here, appear to compress the distance between near and far objects. Despite these appearances, the geometry of the scene is correct. The Earth is roughly